Today's guest is Ariel Scisney. How you doing, Ariel?
I'm doing just dandy. How are you guys today?
Great. Thanks for coming back, man.
Thank you for having me.
How you
Always
doing, Mike?
A pleasure.
Oh, I'm doing great. It's a great day for a podcast.
Yeah, man. Sunday. Warm outside, finally.
How warm is warm outside for people who aren't from Colorado? What is it like? It's like in the 40s or 50s today, right?
54, I think, today.
Yeah. So warm.
So
Could wear
warm.
shorts.
Yeah.
Yeah. So
absolutely.
Go ahead and introduce yourself, Ariel. I know you got a lot going on right now, so.
Sure. So a little bit of background on me. So I'm actually from the Lakewood area. Grew up, went to elementary school with your daughter as well. And so I went through the whole articulation area of Lakewood from elementary school, middle school, and then finally high school. And then when I graduated high school, I was an international baccalaureate, which just means that all my classes were upper level, and that managed to get me a year off of college credit. I attended the University of Colorado Boulder, where I got my degree in astrophysics with a minor in philosophy. And I finished that in 3 years, got my bachelor's after 3, thanks to that 1 year off. And then also some good calendar planning management with my my credits, like 16 a semester, until the very end when I did like 19 for the last semester to graduate early. So thankfully, with that and money my parents saved, I only had 1 year of debt, which is part of the reason why I left college early, didn't stay for a full 4 years, because I started taking out loans, didn't want to deal with that. After I graduated, I had the opportunity to work at Harvard University, where I did some scientific research on the origins of life. And after that, I spent the whole year, that was a summer internship, but I spent the whole year in Boston working part-time, a couple different jobs. And it was around that point where I started realizing, because I had done different scientific research projects. I'm looking for exoplanets, which is just planets outside the solar system. And then the Harvard research with, it was quantum chemistry is what you categorize it as. So it's the chemistry of how molecules could form into eventually living organisms. And I realized that I really hated the research process. I loved studying and reading about scientific research, but I didn't really like doing it. And one of the components of that was that you have to always write grants all the time, right? You basically have to ask permission to do certain research. And I was like, you know what? I'd rather just fund my own research, but that's going to take a lot of money. And I didn't go to school studying business or anything like economics related. So I had no idea how to make money, really. And that was never like a worry until then. So after finishing my internship, I had a lot of free time living in my own place over by Boston area. And that was that point where I started studying how, the wealthiest people accumulated their wealth, and started learning about businesses, investment, real estate, finances, all those things. And along the way, I got connected with a guy who's from the Denver area who took it upon himself to sort of take me under his wing, and he's been my business coach, a guy named Tim, and he really kind of just was able to educate me on all types of different financial stuff, how to be a wealthy person in general, and I kind of used that into starting up some businesses of my own on the side. I work as an academic coach right now, have online business, and been doing that since 2018. And just recently, a major life event happened where my mother passed away last summer at the end of May. And so I inherited all of her assets, and I was able to use those to start investing into the market, because she had a lot saved up. I inherited her retirement and then used all the rest to pay off my student loans. So now I'm debt free. And that's allowed me to focus a lot more on philanthropy, charity, my nonprofit, which we can talk about a little bit more later with the Jefferson County Planetarium in our school district. And also, like I said, it's allowed me to invest a little bit more. And so I've been spending the last few months like reading annual reports, quarterly reports, and just studying up on companies that I want to own for the long term, and kind of getting more into that active investment role. And then helping other people get debt free, and getting them some more options and stuff in life while I'm working on the side for fun. So yeah, a lot of different things going on. And then of course the book that I published in 2017, that was just all the different types of ways. I basically wrote a book with the goal of because I've always been good at writing. That's kind of where my best grades were, you know. And so I was like, well, that's a good source of residual income, get royalties from that. So I'll do that. So that's why I chose to write a book. And then the book itself was kind of my way of trying to, I guess, justify all the schooling I took. So the whole book is sort of a recap of all the schooling that I'd learned and trying to put into words how it can actually be useful and why it's good to educate yourself, even if, like, you may not use linear algebra when you're doing your taxes. It's you never know how information might be useful, and so that's kind of the spirit of the book. Is it's good to learn, and that's pretty much where I'm at right now.
Yeah, we have your book here. You gave it to us last time you came.
Yeah, I thought it was really cool that you guys had that ready to go.
We left it here.
Perfect.
Kind of people have been bringing stuff, and we just leave it laying around here on the desk.
That's fun. You get a whole memorabilia list from all your past guests.
Yeah, everyday things with a cosmic perspective.
Yes, and so the meaning behind that, everyday things, just stuff that we all deal with day-to-day basic, everything from like stuff you don't think about too. So for example, how you get your food on your plate, all like the agricultural process, the history behind that, and the development of civilization, and just connecting pieces. I was thinking earlier today actually about like the way that I sort of thought about writing the book, because you can look at the surface like I'm connecting a lot of seemingly unrelated topics and points, but the goal is to build a bridge. So if I'm not good at explaining something, it might seem like I'm trying to connect two ideas like two different islands that you can only have one person walk across and people can't follow what I'm saying. But the goal is to expand that bridge so you have two unrelated topics seemingly, but to find a connection and to sort of build a network of information that way in people's heads. Because as we'll get into probably throughout the podcast, there are a lot of things that we have happen in our day-to-day lives that are connected in ways that we don't normally think about.
Yeah, I didn't remember that you mentioned that you studied philosophy last time we talked.
Yeah, my minor was in philosophy, and that was just like, this is my recommendation to all my students too, because I part of the academic coaching is a lot of college students that I work with. You have to take core classes anyway that are outside your major. So if you take them all through the same department, that's like a free minor. And that's just what I did. So every semester I did one physics class, one math class, one philosophy class, one astronomy class. And then that was pretty much it. And I had all my core classes taken care of from high school.
So does philosophy help with astrophysics, do you think?
So philosophy really is kind of just for fun. A degree in philosophy is basically useless, I'd say. Because if you like philosophy, you like looking into various different perspectives on the world, a lot of contradictions sometimes, and you just like thinking for fun a lot of times. But that doesn't translate to any specific field, but rather because it translates to all fields, right? When you get a highest level degree, you're called a doctor of philosophy. So it's just really broad. So you can make it apply to anything, but it doesn't inherently it's not like for astrophysics.
That's why I asked, because I think it would, right? Because it gets you to think of different things.
Yeah.
Open your mind a little bit.
So I actually did take a philosophy of philosophy of physics my very last semester of college. And it was just us sitting in a classroom talking about like the different interpretations we focus on quantum mechanics. So many worlds theory, multiverse, like do different things happen when different probabilities can occur, like just different interpretations of quantum mechanics. So that was a nice tie-in, but you can do that with all types of different subjects as well.
Yeah, for sure.
Yeah.
Have you been keeping up with the colonizing of the moon and Mars at all?
A little bit. One of the companies that I just bought, the ticker is Lunar or something. I have to read up on them more, but they're developing technology specifically for the moon. My goal long term, I would say, is I want to own property on the moon. So I know you're into real estate. I think that would be a nice long-term thing. Maybe it wouldn't happen in my lifetime, but maybe my grandkids, because we're going that direction.
Yeah, I rent a lot of places out my real estate. So if I had one on the moon, it might be hard to collect the rent. I don't know how that would
probably
work.
would be. It'd probably be one of those things where it'd be a pool. You'd have like a share of
company,
something.
right?
Yeah, you'd have a share of a company that would own land
I'm just
on the
kidding.
moon.
I'm just kidding.
Those wire transfers would take a while.
Yeah.
Well, not necessarily, because it only takes like a little over a second for light to travel from the moon to the Earth. So.
Yeah, I'm just kidding.
Stand corrected.
Yeah.
But wiring always takes a long time anyway, right?
Yeah.
Like if you transfer between banks, it's a couple days. So.
Yeah, for sure. What do you think about that? The whole colonizing of the moon and Mars. I think it's pretty cool. I mean,
Yeah. It's necessary, long term. Not in the scale of a few generations, like even over the course of hundreds of years. But the bottom line is the sun's going to go out eventually. We have like 4.5 billion years, which is a lot of time, but it's going to go eventually. So if we want life to continue, we got to leave Earth eventually.
We would have to leave this
whole solar system. The first step is the moon. Yeah.
Right. Because we couldn't stay at another planet in the solar system and still be safe by any means.
No. The best bet. Actually, I think I just saw something about how Titan, which is it's the only large moon in the solar system that has a thick atmosphere, is Titan. It's the biggest moon around Saturn. And just recently, they're starting to think like, okay, well, because it has weather. Except instead of liquid water, it's methane. So they have methane clouds, methane rain, stuff that's normally a gas that you'd use as fuel here on Earth because it's so cold out there. But they're saying, okay, maybe Titan wouldn't be an option. And then you have other ones like Europa, which is one of the moons around Jupiter. That's got more liquid water on it than Earth does. So that's an option. But are people going to live there? Probably not. Right. So the moon, definitely good. And that's why I say the moon and not Mars, by the way. So I'm not like Elon Musk where I want to live on Mars. That's too far away from me. But the moon's pretty close, relatively speaking. So that's a good place for a base.
Isn't the moon... I was telling Jeremiah the other day, I had not been paying attention to this whole Artemis mission, and it kind of just like snuck up on me. I started reading about it, and I was like, what?
Yes.
We're building a base on the moon, and then we're mining the moon, and then we're using that to like get out to Mars, and it it seems like all of a sudden like we're living in the future.
I think they're talking 2030. They want people on the moon.
Yeah, they've got missions ready now, I believe.
Yeah, I read to
they've already selected astronauts.
2026, there's supposed to be people on the moon.
Yeah.
And then I think 30 is when there's supposed to be people actually like living on a base on the moon, right?
Long term, yeah. I mean, I haven't kept up with Artemis too much. I've known about it pretty much since its inception, but I don't like keep up with news about it. So I'm not sure what the time frame is that they're planning, but long term, it's we're sending people back to the moon this decade.
So NASA is targeting September 2025 for Artemis 2, the first crewed Artemis mission around the moon, and September 2026 for Artemis 3, which is planned to land the first astronauts near the lunar South Pole, and then Artemis 4, the first mission to the Gateway Lunar Space Station, remains on track for 2028.
Okay, so they're starting the process of building the station. Yeah, because that's going to take some time.
Yeah.
So we're going to ask you a bunch of questions about planets and stars and all that stuff. If there's anything else you want to talk about, please just say, that's cool, but check this out.
I'll segue, but I'll try to keep it in line. Yeah. Ask whatever you like. It's everyday things, right? So
because I have an astrophysicist in front of me who, studied, exoplanets, and I'm like, okay, this is interesting.
Mm-hmm.
Another question that I had is how. So I heard that there's stars being born every year,
all the time.
Like all the time.
Yeah.
Like how many stars are born every year?
Oh, like for a number? Well, I mean that. Okay, so there's the cop-out answer, which is if the universe is infinite, then there's an infinite number of stars being born all the time. But it's I honestly don't remember a number. That's like that's something you could look up pretty quick, so I wouldn't have a number memorized.
And then stars are dying
all the time.
So solar systems like ours are dying.
Yeah.
So if the universe going to live forever? And if you have new stars being born, then I would think that the universe would continue to go on. But I've also heard that the energy will eventually dissipate and there won't be any more energy. So how does all that work out?
Great set of questions. So there are a couple things to break apart with there. So just in general with the time frame of how we observe things happening. So the principle of it is the universe over time started off very hot and very dense, and as it ages, it thins out and cools down. That's known as entropy, which is the second law of thermodynamics, which is just like, things get messy over time. The nature of the universe is towards disorder and things being split apart. It goes from unity to disorder, and things are spreading out and thinning out, cooling down, and eventually everything will go dark. At least that's what it looks like because the universe is expanding, and that's something you can
Yeah, it's just like making a lasagna in the oven. You pull it out, it's hot. It's all the heat's concentrated in that one thing.
Yeah.
You set it on the counter.
Yeah.
Let it sit there for an hour.
And the heat escapes.
It's going to dissipate.
Yeah, and that's entropy. That's energy dissipating. So with the idea of stars being born and dying all the time, so at beginning of the universe, it's all just hot plasma, dense, fundamental particles. They coalesce over time, and you start getting fundamental particles like electrons, quarks, which make up protons and neutrons. Eventually, protons and neutrons start binding together to make the basic elements on the periodic table, the hydrogen, the helium, lithium. Those gases then eventually condense to form the first stars. So you got the first stars born at this point. We're talking like, there's no visible light passing through the universe till 100,000 years after the Big Bang, roughly. The first stars would have formed a couple million years after that. So after the first stars are born, if they're big enough, what stars do is that the reason they are bright and that they shine is nuclear fusion, right? And that's the process of smashing those fundamental atoms together, like helium, lithium, mostly hydrogen, and making heavier elements out of them. The whole periodic table, everything on the periodic table of elements that you see in your chemistry class, all that is formed during the life cycle of stars. And the heaviest ones are formed after the star dies, and if it's big enough, and when it explodes. So that's what a supernova is. That's where you get your gold and all the, uranium, all the heavy elements. Those elements, now that they're formed, don't naturally break down unless they're the bigger ones that are radioactive. Most of them are just stable, though. So you can't split them back apart, go from carbon back to hydrogen without putting in a lot more energy. The energy is kind of already in there, kind of stuck that way, essentially. So as we get farther and farther along the time frame of the universe, what that means is stars are getting heavier and heavier because now those new gases, those new elements are condensing back in to form the next generation of stars. And as you go farther and farther along, eventually you run out of the basic fuel, which is hydrogen, the lightest element. And all that you're left with are inert gas. And then the last stars that'll be alive are the small red ones. Those can live for about 1 trillion years when they're still fusing hydrogen and helium. And because they're small, they last longer. But the bigger ones, they can't even form anymore because you need to start with hydrogen fusion. So if that's not an option anymore, then you're just left with the last ones, which don't explode anymore. They just sort of puff out their layers like what the sun will do. And then at that point, you're just left with black holes. So because energy is always thinning out, that idea again, and things are getting farther apart, then gravity is not going to be able to condense gases back in to form new stars eventually. So all that together is just a long way of saying that it gets harder and harder and harder to make new stars over time and eventually just run out of fuel. And then maybe the universe splits something and then a new Big Bang happens. And who knows? But generally, that's the idea. You go from hot and thick and dense to thin and cold and dispersed. And that's just the time frame. Generally.
So the big stars that we have now, no more of those are being made at this point.
There are, yeah. We're still in the phase where you can see all types of stars being born. And the place where that happens, if you look up like those pretty pictures of space and stuff, those happen in nebulas, so in those gas clouds. Popular one is like Orion, the Orion Nebula. That's a stellar nursery. Stars are being born there of all different types and sizes. And then they migrate and they move, and then it just depends. If there's an area with enough gas, we still have enough gravity in like the whole of the universe that matter can coalesce and form into all different types of stars. We're talking in the scale of Googleplex years, like 10 to the 10,000, like long spans of time.
So if a star is born in that nebula, and you said it moves, where does it go?
Well, it just free floats, like how the sun moves, right? I think we talked about this last time, how you've never been in the same place twice in your whole life, because the Earth is moving around the sun, and the sun is moving around the Milky Way. And the Milky Way itself is on a collision course with the Andromeda Galaxy, and it has smaller dwarf galaxies orbiting around it. So we're always moving. Everything is always moving all the time anyway, just from interacting with other objects, gravitational forces, things as small as like light exert pressure. And that's like on the smallest scale, all the way through. So things are always in motion. The universe is in constant flux. That's just sort of the nature of things.
Do you guys have an animation of that in the planetarium?
Oh, yeah. That would be...
Or is that at the Boulder Planetarium has that?
Everything would be better in Boulder, generally, than at the Denver Planetarium. The Denver Planetarium's more like the one in New York where they kind of just let people in, they show a movie, and then they leave. Whereas in Boulder, they do live programs, and they have like customized animations for things. I think Planck CMB, Cosmic Microwave Background type stuff. But yeah, in Boulder, they'd have simulations of that, of the first stars forming and first galaxies forming. So any scale that you want.
I've always wanted to see how the Earth moves, because I always stand outside and I like wonder, okay, where am I at now in relation to the universe?
So the way that you would do it is you tilt yourself 23 degrees, right? Because that's the tilt of the Earth, and then you spin kind of like that. But then you'd have to walk in a circle while you're doing that, and that simulates the Earth spinning on its axis like a top, but then revolving around the sun. But then the sun, right, is moving through the Milky Way. So it kind of makes a spiral shape. If you watch the Earth is the spiral moving around another spiral. So it's kind of like that. It's like a spring shape almost.
And you're never in the same place in space.
Ever. Not in your life. You've never once in your life been in the same place twice.
Wow.
Ever.
If you imagine space as air, for example, and you throw a rock in the sky, and I can throw a rock in the same area.
But the Earth moved.
Right.
And the sun moved at the same time. So the Earth is moving in 3 dimensions.
I don't think I've ever heard that we are not. Did you mention that?
I might have been passing. Yeah.
Yeah, that's crazy.
I don't know if I emphasized it very heavily, but yeah.
I thought we came back to like the same spot.
Never. No, because the way the Earth is tilted relative to the Milky Way, it's a little bit offset. So that's why it's a corkscrew pattern. But yeah, so if this is the sun and this is the Earth's moving around like that, and then it's moving in a circle like that.
It's kind of like that stencil thing you used to do when you were a kid. It had the little gear stencil things you do on the paper.
Yes. Oh, yes.
What was that called? Stencil something?
I know what you're talking about, but...
And you do the lines, and you kind of... You do cross some of the same lines, but you're kind of creating new circles the whole time.
Yes, but then imagine that the paper you're drawing on is also moving while you're drawing.
Oh, yeah.
Right?
So you wouldn't be. So it's almost like a slinky going in different directions.
Yep. That's what I meant by spring. A slinky, yeah. Same thing.
Got it.
Yeah, good clarification. Yeah, because a slinky, that's more relatable. Yeah.
According to the Curious Times, back to stars real quick. It says there's 50 billion galaxies in the observable universe. About 150 billion stars are born every year in the entire universe, and that means there's about 275 million stars being born every day. And then, according to Astronomy magazine, it says on average, roughly 6 to 7 new stars form the Milky Way every year.
Wow.
That's a better one to wrap your head around, I think.
Yeah,
6 to 7 just in our local neighborhood.
Got to look at things a little bit smaller to make sense.
Yeah. So, and that's kind of one of those things.
Every day?
Like, every day.
Every day.
Yeah.
6 to 7 every day?
No, year.
Day.
Oh, sorry.
Every year.
Year in the Milky Way. Yeah.
So like one every 2 months in our...
Yes. And so...
in our galaxy.
Yeah.
And that's kind of a good idea to get... Because the Milky Way is pretty big. So
what if you could see that? Like, not just in a telescope to see, there's a new light. What if you could see it from a distance and watch the show?
Well, you'd have to live for several million years to see the whole thing play out. It takes a long time for a star to form. It doesn't happen like that. It happens over the course of there are different phases that people can look up to that they go through in all textbooks, where it starts from like a protostar, which is just the gas, and then actually before that it's just the hot gas, and then you get a protostar, and then nuclear fusion with hydrogen finally starts happening, and then it's like we call it the main sequence. That's like its normal lifespan. For the sun, that's like 10 billion years. And then after that, it starts fusing heavier elements, and then that's when it gets to its old age and starts dying. But they're all life cycles.
So when this says 7 are born every year, what moment does that mean? What phase does that mean?
So that would be after the protostar phase, when it starts fusing. The second nuclear fusion starts, that's a star. That's like the definition of what a star is. It's an object of hot plasma where nuclear fusion occurs.
So that takes a long time for that event to happen?
Yeah, because you have to think what nuclear fusion is. That's smashing protons together. And if you've ever played with magnets as a kid, you know, like charges repel each other. Obviously, magnets, it's north-south, and then with electric charge, it's positive-negative. But it's the same concept, and then electromagnetism kind of are all under one umbrella. Anyway, but the point is, the protons don't like each other. They want to repel each other. They shoot away from each other naturally because they're the same charge. So how much energy you're going to need to shove them together to the point where they stick together, right? That's why it only happens in stars, is because the only way that's possible is with so much gravity. You have to have all this stuff piled on into one place to the point where the core is squished to the point where fusion must happen. And that produces energy. That's why they shine.
That reminds me of something. There's a guy on YouTube. He has a big magnifying glass, square.
Okay.
He has it kind of like on an easel. And he puts stuff on the ground or on this.
Oh, it's his. I know this guy. It's the death. He calls it his death ray.
Yes.
It's the man. What is it? It's the front layer off of an old like big screen TV or something, I think. And it's like he bent it a little bit so it collects the light and then points it.
Yeah.
Yeah. He just like put it on a wood thing. Yeah.
Yeah. So he put some magnets down there, and he concentrated the sun right on those magnets, and they lost their magnetism.
Yes. So the reason that happens, this connects with superconductors and then supermagnets too, because again, electricity, magnets, it's all kind of the same thing. But if you chill a magnet, you'll notice that they get stronger. And if you just like look at a magnet on that you put in a fridge, like a basic one, and you heat it up, you'll see the same effect. So when you heat up magnets, they lose magnetism. The reason for that is because the reason they're magnetic is because on an atomic scale, the way the electrons are moving creates the magnetic field. And then if you have a whole lot of atoms aligned, pointing their magnetic field in the same direction, then the whole object is magnetic. But if you disrupt that and they start pointing in all different random directions, then they cancel each other out, and so the object as a whole is no longer magnetic. And so when you add energy, that electromagnetic radiation, the light, right? Because that's what it is, electromagnetic radiation, that excites and moves around those electrons, and now they're no longer aligned with each other, so the object's no longer magnetic. So it's not necessarily the light itself from the magnifying glass doing that. I'm pretty sure it's just that it's getting hotter. It's just making it hotter. Right. Yeah.
And so that's how like electromagnets, they have them. I think like welders use them. You can just turn it on and turn it off. They're super strong, and I'm assuming that's putting some sort of electrical pulse to.
Yeah, and this is a thing that you can do at home too, is if you just plug something in, you have one of those basic compasses that you just take out in the wilderness. You just put a compass on top of a wire, turn it on, you'll see the compass move. Because the wire has electrons moving through it. When charged particles move, like electrons, they create a magnetic field. And that happens more easily when it's colder. So things, like objects are more generally conductive if they are at all. So magnets are better in the cold. That's why superconductors, that's a big problem that we're having, right? Is that we can't, the trouble is that they can't keep them cold long enough. And so that's one of the reasons why cryotechnology is like at the forefront of a lot of industries right now, like those trains or super speed light rails. They use supermagnets, and the problem is you have to keep them cold in order for them to operate.
So how do stars have magnetic fields?
Good question. Because they're made of plasma, which is just, all the stuff that we're made of, but you strip the electrons from the core nucleus, so the protons and the electrons are flying separately. Because they're charged, they have electric charge, positive, negative. When they move, they make magnetic fields. So the reason that stars have magnetic fields is the same reason planets do. It's because there's enough charged particles moving that there's an aggregate, whole magnetic field being produced around the object. And then because stars are made of plasma, they're more fluid. So if you look up the magnetic field of a star, for example, it's not like the Earth where it's a nice concentric circle, like a shield around the planet. It's more like just a whole bunch of smaller magnetic fields. And that's the reason that if you know what sunspots are, those dark spots on the sun,
right?
Those are from the magnetic fields.
They're cooler, right?
Yes.
Yeah.
Mm-hmm. Yep. So some of that energy is being sapped out into the magnetic field, and because they're colder, they're still brighter than the brightest flashlight, but compared to the sun, they look black.
So the
reason they have magnetic fields is because they're made of charged particles.
So the heat from the sun and the energy from the sun doesn't diminish the magnetism or the magnetic fields?
It interacts, but with the heat aspect, so you just have to remember that heat is infrared light. So if you have a whole spectrum of light, that includes everything from radio waves, microwaves, and then infrared, which is what we interpret as heat, then visible light. But it's all still the same thing, just different energies of photons. So those won't necessarily take... I'll put it this way. It's all a store of energy, and then you can parse it out in different ways. So some of it will come out as visible light, some of it will come out as heat, some of it can be stored in gravity, some of it can be stored in the magnetic fields, electric fields. So because energy can transition into different forms, it can go in between. So it can be concentrated in the magnetic field and then released out in a solar flare. And that's converting it into kinetic energy because now those charged particles are moving. So then they carry the energy that way. So I guess yes is the short answer.
I did see some videos I was watching about the magnetic fields on the sun, our sun. They are a little chaotic.
They're very chaotic, yeah, and they're shifting all the time because, again, it's one giant fluid. Nothing is stationary for a long period of time. It's constantly flowing all the time. And because what that flow is charged particles, when charged particles move, they make a magnetic field, so there's all types of magnetic fields being created, destroyed, broken all the time, in and out of every star, including the sun.
Yeah, can you pull up that video that I told you about earlier? I wanted to show people.
Oh, with the scales?
Yeah, just this thing blows my mind. I seen this the other day, and it just blew my mind. Because if you really pay attention to this video, it is nuts.
Mm-hmm. So, I guess if we have it up, if you don't mind starting from the beginning. I know if that's okay with you, Jeremy. I know you want to start at Earth. But this one's good just for folks to know. So Ceres is in the asteroid belt in between Mars and Jupiter. That's a dwarf planet just like Pluto is. And so you can see the kind of sense of scale of what the smaller planets are. And then Europa, which is one of the main moons of Jupiter. Notice how these objects are larger than some of these dwarf planets, which is another reason for the categorization, not calling them planets. Obviously, we have the smallest one, Mercury. Another moon is bigger than a planet, again, Titan.
So what I want people to see is just how crazy big things are compared to like the Earth.
Mm-hmm. So I guess for a sense, if we pause it right here real quick, just so we know how big we are. So obviously you can see the United States right here in this photo. That's perfect. Just for scale, because this is all outlined in chapter 3 of my book too, you can see to the horizon about 3 miles. If you're an average height person, you can see out to the horizon 3 miles. And then if you multiply that, it's like 1.5 kilometers. I have to do the math again, but so if the radius of the Earth is like 6.5 kilometers, you could double that, multiply it by pi, so like 1,200 times 3 roughly. That would be the circumference of the Earth, and that's how much farther around you would have to see if you were to divide that by 3. So if you look up like the circumference of the Earth, that's how much bigger it is than as far as you can see. So now if we play the video, we're gonna compare that
So hold on, pause it right there. So are you saying, like, on a planet like Kepler 22b, that we can see further?
No, because
Okay.
that's based on your height. So like the distance you can see far away is just based on how tall you are and how far you can see at the horizon. So like if you're standing in a tower, right, you can see farther.
Okay, then
versus if you're in the ground. So that doesn't depend on
in
where you are.
layman's terms, explain to me what you were saying. Because the Earth is like what, 24,000 miles around.
It's a ratio between the circumference of the Earth and how far you can see. So it's just a way to get a better sense of, okay, so if I can see that far, then the Earth is that much farther around, and that's like how big the Earth is. So that's stuff that
it's just for a sense of perspective, something you can walk out and compare this to.
Yes.
I see.
Yeah.
Okay.
Yeah. So then we get to largest objects.
So
in our
for anybody
solar system.
watching, you know how much bigger like Saturn and Jupiter are than our planet. But wait till you see some of these other planets. Our sun, of course. Can you pause it right there?
Mm-hmm. Perfect.
Down there to the left. What is that? I think one next to... Yeah. So that first small one.
Yep.
Past Kepler. That's us.
Yep.
And what we're about to get into, this is the part that blows my mind. The next stuff.
Do you guys know, since this is a perfect spot, do you know how many Earths can fit inside the sun?
I thought it was 1.2 million.
Yeah. Yeah. And that's like if you melt the Earth and fill it up to the brim. There's actually a funny little experiment you could do, because if you pile spheres into a sphere, so like put marbles into a spherical container.
Void spaces.
Yeah. You'd have void spaces. Yeah. So, but it's like 1 million. Yeah. So that's perfect right there.
This is where it gets nuts. Not even this one. This Sirius A looks small here in a second.
So Sirius A, that's the brightest star in the night sky, right next to Orion, if you want to look for that in the sky.
So note that you can't even see the Earth anymore.
I think you still could on the screen, but
It's
here
like
in a second, you're not going to be able to.
That's Sagittarius A star. That's our black hole in the center of the Milky Way. Aldebaran, that's the Eye of Taurus, the bull.
Look at this.
Or
This is nuts right here. This is crazy. You can't even see our sun anymore on that. Like, our sun is the smallest dot to the left there. It's about to be gone. That's crazy. And this thing is small compared to other things. This is nuts.
Yeah, hard to. I mean, even this is probably the best example you could look at. Still hard to wrap your mind around.
So these ones right here are gonna disappear like our Earth did in a second, on the graph here, or on the size.
I also just checked. Didn't want to make a fool of myself. But Aldebaran's in Orion, which is next to Taurus. It's a different red star. That's my bad.
So now even those crazy big things are gone. You can't even see them anymore in a second here. So these are black holes. Kind of hard for people to put in perspective. But if you had another sun... Oh, so this is the...
So now we're getting into the nebula here.
Right.
And so these ones, not all of them are stellar nurseries like this one right here. This is what the sun would look like. This is a planetary nebula. Smaller stars, when they die, they just puff off their layers. This is a larger grouping of clouds.
How big is is one of these compared to like our oh wait, there we go. That's a galaxy.
So you can see now they're using light years instead of miles and kilometers. So the closest star to us is 4.5 light years away. Closest star for scale.
So unless we find another way to travel, we are not getting to any of these things anytime soon.
No.
Yeah, to think that
Here, pause that.
Traveling at the light of speed was like the pinnacle, Like I always used to think that's the pinnacle. That's the fastest you could ever go, and then to realize that you could basically go nowhere if you're traveling at the the speed of light.
Well, doesn't it say on the top there how fast a light year is?
Well, so a light year is a distance, right? It's the distance that a beam of light travels in 1 year.
Right.
So the speed of light's a constant in a vacuum. And that's why we use this as a measuring stick. So if something like the Milky Way is 100,000 light years across, that means it would take a beam of light 100,000 years to go from one end to the other. So the closest star to us is 4.5 light years versus 100,000 for the Milky Way. And that's sort of the sense scale. And then it's 25 times that to the Andromeda Galaxy, so 2.5 million light years away.
Yeah, I just wanted to show those other planets. I don't think there's any more there's obviously no planets there.
And it does say at the top here, let's see, 1 light year equals 9.46 trillion kilometers.
There you go. Which sort of doesn't even mean anything at that point.
Yeah,
like
it's like
what? Trillion kilometers was.
Yeah, people are. Yeah, you lost me there. It's like what?
Yeah, and even like professional astronomers, they don't even use light years at this scale. They use something else called parsecs, which.
Oh, this is the.
Well, that's what the Millennium Falcon did. Something.
This is the known. This is the visible universe right here. I think it's not a planet.
Yeah. Okay.
Yeah, the observable universe. Yeah.
Mm-hmm. And why they made it white, I don't know. That's kind of funny. Usually they just use the cosmic microwave background.
Yeah, it's not bright
shape.
Like that.
No. Otherwise, the night
full
sky
of bright
would be
things,
black.
but
yeah. The funny thing about Star Wars with the parsec thing, I think they use it as a speed. Like we're gonna go this many parsecs.
Yeah, they said he cleared the something in however many parsecs. Yeah, they did use it as a time frame. I think. Yeah, is what they used
and that's totally wrong. It's a distance. It's a measure of distance. It's from a parallax, which is something you could do with your own. Like if you look at your thumb, if it's closer to you and you blink one eye versus the other, how your thumb moves with your eyes. Mm-hmm. That effect is what we do, except replace your eyes with the Earth, and instead of blinking, you just wait 6 months when the Earth goes the other way around the sun. So objects will move the same way your thumb moves. This is like, let's say, January. Gotcha. This is June.
Yeah.
So if you measure the same thing, if it's close enough, you'll see it move. And if you know how much it moves, you can do geometry to calculate how far away it is. That is kind of how we get a basic parsec, excuse me.
Of where things are at.
Yeah, and then it only works for close things, so we have to use other methods to figure out how far away other objects are, like measuring the brightness of supernovas, type 1a supernovas. That's the most common example, but using the unit of parsec is easier for big scales of things. That's why you'll see that instead of light years. But
can you pull that video back up? I want to ask Ariel a question about something. So with some of those other stars, go to the stars. So some of those big ones, like those. Yeah. What is the closest one of those to us? Those big ones.
So the closest one.
I guess it would be
Proxima Centauri.
Oh, that is distance, right?
What?
That's size.
That's how big they are.
That's size at the bottom.
Sorry.
Yeah.
So keep letting it play. Which ones of those are the closest to us? Like the super big ones. And my question is, the closest one to us, if they're that big, then how come we don't get light from them?
Well, I mean, you can see them.
They're that far away?
Well, yeah. I mean, you do get light from them. That's how you can see them, right?
Yeah. But they don't light us up. Like.
Yeah.
So they're that far away.
Yeah, and the principle behind that, it's called an inverse square law, which just means with brightness, if you go twice as far away, you get a quarter of the brightness. Oh. So like 2 squared. That's why it's an inverse square. So that's just how light works in general. If you double the distance, then it's a quarter of the light. If you quadruple the distance, it's 1/16 of the amount of light. Oh. And that's just because it spreads out as a sphere. And, surface area, that's squared radius. So
I've never heard that before.
Yeah.
Kind of like radioactive decay, maybe like over time.
Radioactive decay is usually exponential. Obviously, there's half-life, which is sort of similar but in the opposite direction, and that could vary. So the curve for like radioactive decay, that's usually like a hockey stick shape kind of thing, versus something like, I don't know, like brightness and distance could be more linear, that type of relationship. So, it just depends on what you're talking about.
So this says the nearest giant star is Pollux.
Okay, and that was on the video, I believe. Pollux was up there. The closest star system to us is the Proxima Centauri. You can remember, like, Proxima, like close proximity. And that's not in this animation, I don't think. But
yeah, but it says nearest supergiant is Polaris, and then the nearest brown dwarf is Lumen 16.
Okay.
Lumen.
So in order for it to be like bright, so the brightest it could be, and this is like something that has actually been recorded in human history, are supernovas. And if you were to see a supernova happen in the Milky Way, so in our neighborhood, it would only be about as bright as the moon. So it would be visible during the day like the moon is, but that's about as bright as it would get. And you have to remember, like a supernova, those are the most explosive, dynamic, energetic events in the whole universe. And those are still only about as bright as the moon, because things are just so far away, right? So you saw the scale of things, hundreds of thousands of light years to, millions of light years. And the closest thing to us is 4.5 light years. And the sun is 8 minutes away. So compare 8 minutes to 4.5 years. And that's the closest thing to us. And that's how far away the closest thing to us is. So anything farther than that is just going to get dimmer and dimmer,
right,
at a squared rate.
So if a supernova happens in our galaxy,
Mm-hmm.
and it's nighttime, it'll light up the sky like the moon would at night?
Yeah. It'd be about that bright.
That would be nuts, though.
Yes. And this happened with where the Crab Nebula is. I forget. It was after Common Era, so I want to say it was a little over 1,000 years ago. But there are recorded like sightings of some supernova events, even in cave paintings. There are some.
How long would that last?
I believe only a couple days, maybe a few weeks.
Wow.
Yeah.
That's pretty cool.
It's a pretty magnificent thing. Very rare that you would see something like that. So look to Orion. Maybe one of its stars, Betelgeuse, will explode here in our lifetime, or not. It might have already exploded and we wouldn't know, because it takes time for light to travel, right?
Mm-hmm.
So by the time you see a supernova, that means it probably happened like, I don't know, a few thousand years ago, maybe.
Wow.
Yeah.
So how's the planetarium going in Lakewood?
Good. So we have...
What's the name of it again? Sorry.
It's Robert H. Johnson, named
Robert
after...
Johnson.
And I just found this out. He was the superintendent at the time that the building was first put up in... it was 60 years ago last year. So that would have been 63. Yeah, 1963. So it was named after him. We're at the point now where we're consistently having our monthly meetings. Our goal for this year, we're getting back out. We've sort of got a little collaboration going with Red Rocks Community College, where they've supported us about Railbuilding Planetarium and have sort of looked into some grant stuff, and they've invited us to some events that they have with their astronomy department, where we can do fundraiser events. And then I'm looking to, because Jefferson County just got a new chief operating officer, a COO. He's the guy who can let us into the building. The previous guy that let us in, he retired. So I've been trying to get back in touch with officials in the district to get access to the building again. We've got a new member in our committee who is a VJ, a video jockey, like a DJ with music, but he does special effects in the planetarium. He travels all around the country and around the world building full dome theaters. He actually helped put up one of the things for the Super Bowl. Last Sunday, he did one of the projections in Las Vegas that went up there. So he's been helping us out. And then last year, part of my charitable contributions, I put my own money in. So we only raised a couple thousand because we weren't officially a nonprofit, and so I didn't raise a lot after that. But I matched all those funds with my own. And so that's like a total of like 8,000 or 9,000 that we've raised, including what I've contributed. And we've used that for advertisements online. And that's kind of where we're headed, just getting more people aware this year. And then seeing if we can do some more volunteer events just to raise awareness. And hopefully the goal long term is just to get Jefferson County to take care of the building maintenance. And then if we can get Red Rocks fully on board, they would take care of the staffing. And that would allow for students of various different ages, because it used to only be elementary school students allowed in that building. The goal is to have all age students come in, be able to work and do maybe internships or stuff like that. And so a lot of trying to get on the same page as the district and see if we can get on their budget is kind of where we're at right now.
How's that going?
It's slow paced. Just the bureaucracy of dealing with like a pseudo governmental organization, because it's public school system, obviously. And so, but I mean, no one's like against reopening the building. I think our current superintendent, she wants to use the building for like a Meow Wolf type thing. Her kids are really into art, so that kind of makes sense. So, I mean, no one's against having the building. It just doesn't seem to be the top priority to be on the budget. So that's kind of where the fundraising aspect of it is coming.
Can't
so now
they sell tickets or something for people in the public to come?
Yeah, and that was my original intention, was like, well, it can fund itself if we just have shows going. Mm-hmm. Maybe not fund itself, but that would at least contribute to like the electric bill or whatever, you know. So, and that'd be a supplemental income to the district for other extracurricular activities on top of that. And then the fact that it's like attached to the school system could potentially have other benefits in a way, like the Boulder and the Denver museums can't, because the Denver museum has their planetarium, but they have to, it's like in the museum, which has its own rules and regulations. And then the other one, Boulder, is on a college campus. So there's some rules with that. With this one, it can be a lot more focused on up and coming growth for younger students, and could support other types of events. Could support anything from sports to like food drives. Yeah, it's any sort of thing. But yeah, the ticket price is just another source of income. So that's an option. But really, it's just sort of hounding them more about just getting it on their to-do list. If that makes sense.
Which school district is this?
It's Jefferson County.
I mean, I'm sure you're aware. Last year they closed 16 schools, I think. Which did that did you have to deal with that in one way or another?
Well, it was part of it. So last spring, all through the spring semester, we had these really cool things where Superintendent Tracy Dorland would have meetings at the different articulation areas with just all the different high schools, where they would have public conversations and people would air their grievances and what sort of concerns they have. A whole lot about the bus system, obviously the school closure thing. That was all elementary schools. And it was, I think, maybe one middle school in there. But it was primarily those ones that just weren't getting the attendance. But figuring out how to get students to events. And then we have this thing where people can learn trade skills, Warren Tech, if you guys have heard of that. So getting buses to stuff like that was a major concern all around. Then obviously mental health was another thing. The last one was actually at my high school, at Lakewood High School, and I finally sort of met there. So superintendent knows who I am. I was going to see about going back in, because I spoke with the previous superintendent just by walking in to the Jeffco office and just be like, hey, can we sit down and talk about this? So we're going to see if I could do something like that again. The trickiest thing is that there are just so many moving parts anyway this is a very large school district anyway, Jefferson County, and it's the most largely funded one, I think, maybe only second to Denver County. So there's so many moving parts, and you just kind of have to be conscious of what people are thinking. But in general, everyone's like, yeah, we should have a planetarium. Everyone thinks it's a good idea. It's just not like their main priority right now. So that's kind of where we're pushing. Just get it in front of them more.
Yeah, well, I hope it works out, man. I'm really interested in it. I'll go if it opens. Yeah. I mean, I want to go to Boulder with you still. Yeah.
I'd love to take you guys there because I think hopefully they sell my book there. I know, so hopefully they still give me tickets. My old boss Tito said I could still get tickets and go in there. And the nice thing too is now that my main focus, at least these last few years, because I started the campaign for the Planetarium in 2019, but I wanted to make sure I was financially secure first, had all my debts paid off, and had kind of ongoing income. And so now that I've sort of achieved that, I can redirect a lot more of my time and energy into nonprofit ventures. And like I said at the beginning, more philanthropy stuff like that. So this year we're ramping up a whole lot. And just got a lot of new clarity this year moving forward. And if we just have more consistent type of events and post more regularly on social media, because that's been my thing, and I'm terrible with social media. I hate using social media, but it's important to use.
It's a necessary evil, man.
It really is. And so
you have to use it.
And so getting more consistent with that, and getting posts out and just getting it in front of people's faces, and because once people are aware of it, they're supportive. So that's just the onus is on me for that part. And now that I have the free time to do that, I think we'll see a lot more progress.
Well, do you have free time? I heard you're writing a second book.
That'll be during the summer. Yeah. So I have a list of articles and books that I could potentially read. The one that I'm going to do this summer, I had planned pretty early on, but I saved it specifically. I didn't want to publish it until after my mother passed away, so I was waiting a few decades, but I can publish it now because I already know what the contents are going to be. And the only reason for that was just there's going to be some pretty personal stuff that'll go more into my childhood that may not be the most edifying part of it. Not that, I wasn't abused or beaten or anything. She was a great mom, but there were some things in there that might make her feel guilty if she were to read them, like, oh, I could have been a better parent. And that wasn't the case, but sort of sensitive stuff like that I wouldn't really want her to worry about, I'm going to publish in that book. So it's going to be more of a autobiographical, very personal, philosophical type thing. Unlike this first book, which is a lot more scientific, a lot more grounded, more for the public. But this next one I'm going to publish this summer is a little more personal.
Nice. Yeah. Looking forward to it, man.
Thank you.
So you talked earlier about investments.
Yes.
I'm curious to know what an astrophysicist invests in.
So on my Instagram profile, I call myself an astropreneur. Astro for space, astro entrepreneur.
I love it.
So that's my title. So for me, I've been, like I said, researching business investment for a number of years. Like as soon as I got out of college, it was like, that was where a lot of my attention and study went. Attending seminars, reading lots of books about those things. I just didn't have the cash necessarily that I wanted to put, like, at least into the market until after I paid off my debt. And so now, after I finally had like a little lump sum of cash to invest, I was like ready to go because I've been waiting a long time. But at this point, it's like if you know Benjamin Graham, who wrote The Intelligent Investor, he's the guy who mentored Warren Buffett, who's like the quintessential billionaire investor. So basically it's that same strategy. My idea is just buy things that I own and understand. And I think that's just a good general rule for everyone. Invest in what you understand. And I understand space decently well. I went to school for it. So that's kind of the area that I'm I've just begun that journey where I can really call myself an active investor. And then other things like I used to work at a grocery store, so I buy stock in them, or a fast food place because I work there. I kind of understand the business model a little bit, so stuff like that. And then the rest of my portfolio is I have it split up into various different index funds, so baskets of stocks for different sectors, and that's kind of just like a barometer to keep an eye on things, and that should grow roughly with the market over time. And then the rest of it's kind of just fun money because I have other businesses that I kind of plan on using as my actual retirement. And so part of my fun money, because this part, you guys probably wouldn't know about me, but anyone who's listening who knows me, I'm a really boring person. Like I don't like sports. I'm not really huge on traveling. I hate leaving the house. I don't do like concerts or any of that. It's just, I don't care about cars or nice houses or stuff. So what do you do with your fun money? Because you need to spend fun money. That's part of your budget, right? That's important. You have to save, you have to invest, and then you should spend some money, right? Enjoy life.
Sure.
So that's kind of just what I'm doing with my fun money right now. I'm just putting it in the market. and buying companies that I feel like I understand, kind of just fooling around with that. And then eventually, hopefully I can use that for, I don't know, my own retirement, or I can give it to my kids, use as college fund. But really, it's kind of just play money, a lot of it. It's technically a retirement account, but because I have multiple income streams, I can be a little bit more risky with stuff.
I don't really invest in stocks.
You do real estate.
Yeah, real estate.
Which is another good part of your portfolio.
Yeah, that I do. I don't really invest in stocks and stuff like that. Just because to me it's a little bit like gambling.
Yeah, and it can be.
Yeah.
It would be if you don't know the company, right? And that's kind of why people recommend getting bundles of stocks.
Sure.
Right. Funds.
Yep.
That way you don't have to actively manage it. You just let it go, and it should just grow. Like S&P 500, that'll grow roughly 10% every year, and that's a pretty secure investment. It'll go up and down, but over time it should rise.
But there was one company that I seen in the last couple of years that I thought was doing some spectacular things. It's Boston Dynamics.
Okay. What do they do?
They build robots. And I think
Nice.
Hyundai, they merged with Hyundai. I don't know if Hyundai acquired them. And then I was thinking, Hyundai mass produces vehicles, so now they can mass produce robots.
Yeah, or they can make robots to build cars. Or
I don't know if all the car manufacturers already use robotics to build the cars.
Yes,
Yeah, that's true. The Boston Dynamics, I'm sure you've seen them before. They're like, have you seen the robots walking around jumping from platform to platform or doing somersaults or backflips?
That's those guys.
Those are, I don't think there's anybody else. Tesla just released a video of their like robot, which was pretty good, but I don't think anybody else is making robots that advanced.
So I seen one with Tesla where they had the 3 robots. One was driving the Cybertruck. One had the Tommy gun, handed it to the other one who was wearing like a cowboy hat, who shot the Cybertruck as the third robot pulled up. But I didn't think that was real. Those weren't real robots, I thought.
I don't think that's
I've
real.
Never seen this.
They just,
sounds hilarious.
I'll try and find the
There's
video.
no way.
They
There's
just
no way
put
that
out,
one's real.
Yeah, they just put out a press release of their most like recent advancement. And it's not as good. Like it's not as advanced as a Boston Dynamics robot, but I think people were worked up about it because they put a video out roughly 1 year ago, and that robot was not, compared to Boston Dynamics, was not great. So the leap that they made within 1 year was what was so impressive about it. I'll find a picture of it. They have this weird like fabric head, and it looks like I don't know. I'll find it. It looks strange.
Well, that's the one on that commercial I'm talking about. I think they had a black head. It was all fabric.
Yes. So I don't know.
But
I'll look it up.
I thought Boston Dynamics had the top robots, and I didn't even think Boston Dynamics were walking around like those robots I seen on that commercial. But
interesting. That's one of those industries though with robotics that's
Boston Dynamics is killing it.
Interesting.
They are building some crazy stuff.
That okay.
Yeah. So these are them.
Oh. Yeah. Yeah, they're a little hydraulic-y kind of still.
Yeah, they walk a little funny.
Yeah.
But it was, and they have that little like smooth face cover.
But still, that's how it begins, right?
Yeah.
And then it escalates very quickly.
Anyone else get Terminator vibes? Because that's what I kind of think about when I see these walking robots sometimes, is how they'll be used in military
So
purposes.
Boston Dynamics, I believe, is building a lot of military stuff. They have those they have the 4-legged pack ones.
Yep. And those are good for like, I don't know, you can use it for bomb diffusing or just carrying
Supplies. Yeah.
Or if you've seen that that Black Mirror episode, there's one where they have robots that look a lot like the Boston Dynamic robots. They're like little dogs and they're chasing people. It's very like dystopian.
Okay.
Well, that's going to be most of the labor, probably, like mining asteroids and mining. And when you go to the moon, you're going to need that support that doesn't breathe oxygen.
Yep. And so all of those, I guess the big ones, so there's obviously robotics, AI, which is interwoven with that, and then like rocket propulsion, space technologies. All those things are probably looking to be the direction that we're headed as a society. So any company associated with those things. So I don't personally understand robotics too much, so wouldn't like buy into a company like that unless I did a lot more research. But all those things are really interwoven, right? Because they, like you said, like we're gonna need that technology for. It's a lot safer to send a robot to collect some minerals on an asteroid or a comet than it is to send a person. And you could have a person who's manning a rocket, and you send out a lot of drones to collect resource and data, and then you just have one person doing that. Or locally, have robots, like you said, already making cars. We'll have them serving our fast food and all those. I was actually chatting with an old friend on Facebook about this, about like the, because everyone's worried, like, oh, you're going to take our jobs, right? Technology. It's going to take all of our jobs. But
our gerbs?
All of our gerbs. South Park reference. Yeah.
Oh, jobs.
Yeah.
Okay.
Yeah. Have you seen that episode?
I don't watch a lot of South Park.
You don't need to.
Yeah.
But
I like South Park.
You're sort of obligated to as a Coloradan, though, I feel like.
Yeah,
I don't know.
I'm not really from here, but I guess that's my loophole.
You're in now. So they actually have an episode about the planetarium. Yeah. And
really?
It's based on this one, our planetarium. Because Matt and Trey, they are from Colorado, right? So,
yep.
But anyway, old reference. But that's the thing where people are worried about, right? Is that they're going to lose their jobs or their security due to AI. Everyone from artists to writers, and then just robots replacing manufacturing jobs. So the whole thing. The way I see it, we're going to have jobs that people don't want to do replace, but then we're going to need people to fix the robots and to operate the AI, and we're going to need new software developers.
What about people who don't want to work? They don't want to work now.
So that's a thing. So do you mean like people younger, like my generation, and
the ones that are trying to get the 4-day work week? And
yes. So
they're
obviously,
not going to contribute to humanity at all.
Yes.
They just want more time to smoke weed and eat pizza.
Yes.
I like pizza, but come on, guys.
Yes. So there are definitely a portion. I think it's a mixed bag, because there's always going to be lazy people, and they're just going to want welfare, right? They just want the government to take care of them or someone else to take care of them, want handouts. Then there's some people who I think see the opportunities in the way that different people are able to generate income, and it's not as much that you don't want to work hard, right? It's just I don't want to work hard doing this.
Yeah.
If I'm going to work hard, that's fine, but I want to do something meaningful. A lot of people are looking to have more meaning in their work, and they don't just want to clock in and do like a standard type job. And the tricky thing too is, at least for my generation, I feel like a lot of us feel like we were scammed into taking on a lot of unnecessary debt, going to school, getting student loans when we get useless degrees. We have to have nice cars. Everyone has to have a car, so you take out a loan for your car. And it's the thing to buy a house, and apparently that's a good store of wealth, which it can be, but not necessarily, right? So people take out mortgages when they don't have the income or when they should be renting. And people are in dire financial straits. They're misusing their credit cards, going to huge amounts of debt, and they have to work, but they're doing stuff that they hate again. So it's not so much we don't want to work hard, it's just I thought it would be going towards something. You just feel trapped a little bit. So there are some lazy people that just don't want to contribute, but then there's another subsection of people, I think, that want to do something more fulfilling.
And it is an exciting time right now, right? With the technology, with the AI, the robotics.
You can make millions on YouTube or OnlyFans.
There's
so many ways of making income.
We're traveling to other planets, soon, supposedly, So that's got to be exciting for your generation as well.